Hey guys, welcome to your 12.3 notes on measures of central tendency and dispersion. Now I know those are a lot of big words, but basically what you'll need to be able to do by the end of the day is to find the mean, the median, and mode. Those are measures of central tendency and range. That's dispersion. Okay, cool. So our key idea of the day is that you can use different measures to interpret and compare sets of data. Here's a word that I'll be talking about a lot today. This word is called, well, I'll put it in orange, an outlier. So an outlier is something that, are you ready? I don't think you're ready for it. You ready now? An outlier is something that lies outside of the normal. So it's something that's super different. An outlier is a data value that's much greater or much less than other values. For example, if I took the height of people in a kindergarten class, I'd have, this kid and then this kid and then this little kid and then this kid and then that kid, right? They're all like 4, 5, 6 years old. You've got the heights of the kids, and that's great. But remember, I said the heights of people in the room. You got to keep in mind there's a teacher here, okay? And his or her height would be much greater than everybody else. So he or she would be the outlier. So the outlier, super different. Okay, now that that's done, let's talk about our main idea, which is measures of central tendency. That is, how does it behave in the middle? What does the middle look like? Okay, a very, very common a very, very common measure is the average. And the mathematical word for average is mean. Ta-da, mean. Like that. And you calculate the mean by, we use this letter U, and by U I mean mu. There's a Greek letter, but it's the Greek M. Here you go. We say that's equal to the sum of the data values. So you add them all up and divide by the total number of data values. Number of data values divided by how many you have. Okay. So if you want to find the average height of people in my 5-person family, you add up all the heights, divide by 5. Use the mean when the data doesn't have an outlier. Because if you have something super different, it's going to pull the average high or pull it low. So if we looked at our example here of heights of people in a kindergarten classroom, the average height wouldn't be around the average height of a 4 through 6 year old. This adult would drag that height real high unless the teacher were super short. Okay. Our next idea, I'm going to split these guys up a little bit. Okay. Another way to look at the middle of a set is by taking the median. The median is literally the middle number. You saw this in the intro earlier. I didn't put it on here, but oh well. Okay, the median is the middle number. That's literally the number in the middle. So in order to find it, you have to write the values in order from small to big. And if you have an even number of values, you need to take the mean of the two middle values. So if you have an even number, you're not going to have a number exactly in the middle, and that's okay. You just take the average of them. So the median is super helpful when the data actually do have an outlier. This should be used when the data don't have an outlier, because data is plural. Fun fact. Okay, and then finally, you can also find the number that appears the most often in your set. We call this the mode. So you literally just count which one that is there the most. this is extra helpful when the data is non-numeric. That is, it's not numbers. For example, if I wanted to find the most common candy that y'all like. Or if you wanted to choose like the most popular thing, especially when we're voting for something. So that's fun. Okay. So what we'll do is we'll look at a couple examples and then we'll decide which one fits best. So we've got our buddy Andrew and his friends went bowling, and here are their bowling scores. What are the mean, median, and mode of the scores? Well, let's start with the mean, because that's what it asked for first. There's a hiccup. Okay, so remember, to find the mean, you're gonna add them all up and divide by how many you have. So to add them all up, we literally just take all the scores. Man, I forgot to turn my phone off. Oh well. Oh man. Okay, I'm sorry. You're just gonna hear my phone chirping. Okay, so add them all up. You should get 104 plus 117 plus 104 plus 136 plus 109 plus 113 plus 104. And we need to divide by how many there are. 1, 2, 3, 4, 5, 6, 7. That divided by 7. So you add them all up, you get 787 divided by 7. And that's about 112.4. So their average score is like 112. And I don't really know a whole lot about bowling, but I think that's pretty good. So good job, Andrew and friends. So that's finding the mean. Now let's find the median. The median is going to be literally the middle number. So let's write them in order. How I write them in order is I look for the smallest one. I think the smallest one is 104. And there's another 104. And another 104. Then the next smallest is 109. And then 113. 117 and 136. Oh, I forgot to cross these off. Where'd it go? Okay, cool. Sweet. Now that we wrote them in order, we literally just kind of like cross them off from the end until we find what's in the middle. So we get rid of not that one, not that one, not that one, not that one, not this one, not that one. Haha! 109 is in the middle. Ta-da! And then finally, to find the mode. What is the most common score amongst Andrew and his friends? Oh, this is the one I wanted. Okay. Mode. Well, which of these scores appears the most often? That would be 104. Ta-da! So which measure of central tendency, those are our green stuff, best describes the data? Well, let's check. Are we trying to choose the most popular? Are the data non-numeric? No, so let's not do the mode. Do the data have an outlier? Is there anything that's super different? Not really. 136 is not that different, especially when you have these guys in the tens and this is such a big range. No, let's go with the mean. The mean is going to be the best description. The mean is the best one. Cool. Because there are no outliers. Okay. Now, this is the classic question that I as a teacher get. And then you guys go, okay. So Ryan comes to class and Ryan goes, all right. So in my tests, I got 80, a 93, and a 91. And I want to average out with an 88 for my test scores. How high do I need to score on my next test to get an 88? Well, let's set up an equation. We're going to say that oops, I spelled let wrong. That's how you know it's been a long day. I'm going to say let X be the score on the next test. Okay. Then his average is going to be 80 plus 93 plus 91 plus x all over 4. He'll have taken 4 tests, and that's how we'll find the average. And we want that average to be 88. So we're going to say that's equal to 88. Now let's solve for x. Let's get x all by itself. The first step is to simplify what x is not. So we add those all up together, and that gives us 264 plus x all over 4 equals 8. Now, to figure out, To figure out what x is, let's multiply both sides by 4 to get rid of that divide by 4. So times 4 times 4, and that gives us that 264 plus x equals okay, I'll say this should have been an 88. This math is not going to work out. Here we go. This will be 352. That's much nicer. Good job, me. And then, to get x all by itself, we'll just minus that 264 on both sides. Turns out, Ryan needs to score an 88 to average 88. That's really funny. Actually, I did not do that on purpose. Awesome. Good job, Ryan. Cool. Okay, so we've been talking about measures of central tendency, which is like middle stuff, helps you find an average kind of idea. If I want to just get a general sense with one number how people are doing. If I want to figure out how spread out my values are, I will use the range. And what the range is, how you calculate the range, is that's equal to the largest value, the biggest value, minus the smallest one. That's it. What's my range? Oh, it's just all these. So if we took the range of Ryan's test scores, his highest test score was a 93, and his lowest test score was an 80. So 93 minus 80 is 13. So the range of his scores was 13. Okay, cool. And now this is where it really gets important. So this is what happened. Mr. Esslinger's class and my class were both given the same quiz. And it's out of 6. And this is their scores. So how did they do? Well, let's figure it out. So when looking at this, for class A, which is Mr. Esslinger's class, I'm seeing that a lot of his scores lie in the middle, right? He's got 12 scores that are a 3 or in the 4. Right? However, for my class, most of the scores are 1 and 2. So they lie to the left. This kind of looks like a histogram, doesn't it? We say Mr. Esslinger's class is symmetric, has a symmetric distribution of his scores, but my class is skewed to the left. All right, now let's find the mean. What is the average score? Now, here's the fun thing. You don't actually have to calculate it. You can just tell by looking at it, because most of my numbers are less than the high ones. But for Mr. Esslinger, they're pretty even. So his average is going to be probably like 3.5 right there. So we're going to say that the mean, just by looking at it, is greater than my class. I should have switched them. I should have the better class. Oh, come on. Now, if we want to find the median, we find the median by crossing out all the numbers. Now, because Mr. Esslinger's is symmetric, you know that his median is going to be 3.5. It's going to be right in the middle, right there. Cool. But my median, if we keep crossing these out, we're going to follow that pattern, and eventually, it's a 3. You guys, my median will be exactly 3. So if you had to look, we would say, oh, yikes, Class A did better. Mr. Essinger's class did better. Again, I should have switched them. I'm sorry, guys. Right. But what's the range? What's the range of the scores? Well, the range is going to be the same for both classes. Take our highest score, which is a 6, minus our lowest score, which is a 1. So our range is 5. So there you have it. We can get some summaries of data by looking at their range, their mean, their median, and their mode. We have a great time on your homework.